Alright, so in this video, I'm going to go over the Chapter 10, Section 1. Chapter 10, Section 1. And we don't want to be there. We would rather be right here. Okay, hold on. Let me fix that again. Let's just go here and duplicate. Duplicate slideshow. There we go. Okay. So we got a lot of stuff to talk about. There's all of our vocab words. The first one is circle. Circle. It's just a nice shape that really traces all of the set of points that are the same distance from the center of the circle. So in this little picture down here below, C would be the center of the circle. And then you can see the circle shape on the outside. Any point on the outside should be the same distance to the center. So if I can write, hold on, I need to get my drawing tool out. Unprepared. Surprise. Surprise, I'm unprepared. Alright. So let's get this back out so I can draw. Okay, here we go. Alright, so all these points on the outside, A, B, E, D, F, they're all the same distance to C. They're all the same distance to C. So if I had drawn a line from B to C, I know that it is the same distance as F. And it's the same distance as CE. And C to A is also the same distance, and DC is also the same distance. So anywhere on the outside of the circle, I can draw a line to the center. I know they're the same distance no matter where they're at on the circle. And those lines that I just plotted on there are called radius, or for plural, that's called radii. And now I have a couple extra that I just drew. So you have CD, CE, CF, but we also have CA and CB now. So great. All right, so radius connects the center of the circle to the outside of the circle. A chord is a segment where it has endpoints that are both on the circle. So an example of that would be like AB. DE is also technically a chord because its endpoints are on the circle. Let's see, what would not be a chord? Anything with the letter C in it is not a chord. Letter C, not a chord. Because a chord has to connect, both points have to be on the circle, and C is not on the circle. C is the center of the circle. So, and diameter, I kind of crowded that picture there, so let me clear this. The diameter of a circle is a chord that passes through the center, so it's basically made up of two radii that are collinear to each other. So it's made up of DC and CE. So a diameter is the measure basically across the circle, but it must go through the center. Please pardon this interruption.
Rodriguez is in the building. Please report to the office as soon as possible. Again, if Melanie Rodriguez is in the building, please report to the office as soon as possible. Thank you.
All right, poor girl. So let's go through. Name a circle, identify the radius. Well, this is circle C, and you can draw that by a little point with a circle. Circle E, I hope I said E. Because E clearly looks like the center. What else do we have? Identify a radius. So we have BE is a radius, and then DE is a radius. Because they both are a point on the outside connected to the center. What else do we have here? They're going to ask a couple extra questions. Let's say these are radii. RAD, is it II maybe? What about chords? Chords connect 2 points on the circle to each other. So AC is a chord, and BD is a chord. But anything including the letter E is not a chord. And the last thing I think we went over on the last slide was diameter. Diameter is a chord that includes the center, so that is BD would be a diameter. I think that's pretty much it. You can see here some of our angle stuff might come back in this chapter. You have vertical angles here that are congruent. So yeah, so like if this line and this line were parallel, you know, then we could have some similar triangle stuff going on here. But that's for a later time. So let's move forward. Identify a chord and a diameter. We'll do that quick. A chord would be WZ, because W and Z are on the outside, or are on the outside of the circle. And then a diameter, we have two of them. XZ and WY are diameters because they have endpoints on the circle and they go through the center, which we're assuming is Q. So, all right, let's skip through some of these. Yeah, we did a radius. The circle is F, and the radius would be Fn. So the answer here is B, which is not a chord. Anything including the center would not be a chord, so that's C, because C has F and F is in the center. Relationship between a radius and a diameter. The radius is double of the diameter, or the diameter is double of the radius. Diameter is 2 times the radius, which is actually what it said right here. And therefore the radius is the opposite of that. The radius is half of the diameter. Alright, so if you have a radius or have a diameter, you can find the other one very easily by either multiplying by 2 or dividing by 2. That's probably something that you are all well aware of already. So let's do some really tough questions on finding radius and diameter. RT is a diameter. If you look at the picture, it says what's the length of QV. Although QV is not in the diameter that they gave me. It's not a radius that is already there. It is a radius, and all radii of a circle are congruent to each other. All radius are the same because they're all the same distance from the outside to the center. So I know that since QV is a radius, it's just half of 21. So I take 21, divide by 2, and I get 10.5. And so my final answer there's 10.5. So I know that this, and this are all 10.5 because they're all radii. All right. What is the length of RV? Well, QS is a diameter, so the radius would be half of that. So the answer here is B. Circle pairs. 2 circles are congruent if and only if they have congruent radii. So if the radii are equal, then they're congruent. So therefore, you can kind of figure out that if their diameters are congruent, then they're also congruent circles. Because if they have the same diameter, they would also therefore have the same radius. All circles are similar to each other. You probably knew that. They have the same shape, but not necessarily the same size. You can't draw 2 circles that have different shapes. They're their own shape. And then the last word here is concentric circles. They are circles that share the same center. So if you think of them as like a bullseye, one is inside the other, but they have the same center. So in this case, we have 2 circles that are both circle A, but they have a different radius. So if you want to decipher between which circle you're talking about, you could include the radius. So like A with circle or with radius AB would be referring to this inside circle because it's the one with the radius AB. All right. So that's all we got there for concentric circles. They are inside one another. All right, let's get down to business. The diameter of X, which is a circle on the left, is 22. So the distance from here to here is 22. The diameter of Y is 16 units. Okay, the diameter of Y is 16 units, which means the distance from here to here is 16. That's not as important as saying what the radius is. So it might be more helpful for me to see that the radius of this circle is half of that. So the radius of the circle would be 8. So that's what I got so far. I got a radius of 20, or sorry, I messed this up. This says diameter. So instead of this being 22, this is actually 11. That would have been bad. In WZ, the overlapping section is 5. So that's 5. Find XY. So we're going to find the whole length of that segment. Well, the length of the segment is both of the radius added together, so 11 plus 8 minus the overlap. So it's 11 plus 8 minus the overlap, which is 11 plus 8 minus 5. And so what do we get there? We get 19 minus 5 is 14. So my answer would be 14. Final answer. Alright, let's try not to make any more mistakes here. Come on, lock it. Let's lock it. Alright, oh, this is beautiful. The diameter of D, B, A, and A are 4 inches, 9 inches, and 18 respectively. Oh, this is a disaster. So what I'm going to do is I'm going to take this segment here and I'm going to kind of space it out a little further. That way I can draw this better. So we have D to C to B and then the whole way over to A. So I'm just taking that smaller area and kind of drawing it a little bigger for myself. This is diameters, more concerned with the radii. So I know the distance from D to C is the radius of that circle. And I know it says the diameter is 4, so the radius would be 2. So this measure here is 2. All right, what's the next circle? Circle B. B is the one that connects the center of D the whole way to B. So from here to here is half of 9, which is 4.5. So, real quick, before I move to the next one, I can do some quick math. And if this little piece is 2 and the whole length is 4.5, and this little piece has to be 2.5. And then our last one is 18 inches of diameter for A. So therefore, the distance from A to D would be 9. Okay, and then I can do some more math there. So I have 2, I have 2.5, and now I need to figure out what adds to make 9. Well, that's 4.5, take off of 9, which would be, what, 4.5 again. So there we've got all of our little segments. What is it asking me to find? It's asking me to find AC, which would be from here to here, which means I have to add 2.5 plus 4.5, which would make 7. So sorry that took a long time, but just kind of map that out. Think of it piece by piece, and there we go. Probably a faster way to do that. Yeah, so maybe we should look at this again and find a different way to do that. It would be the distance from A to C is the diameter of B. Take away this little chunk right here. So if I take the whole length and I subtract out this piece right here, I would get my answer. So the diameter of B, take away the radius of D. So diameter of B minus radius of D. So diameter of B would have been 9, and the radius of D would have been 2.5. Why did I get a different answer? The diameter of B is 9. Take away the radius of D, which is not 2.5, it's just 2. All right. Holy fart, brain fart. Okay, that's good enough. Moving on. Last thing, circumference. I think it's the last thing. Circumference, or no, it's not the last thing. There's more stuff. Circumference equals 2 times pi times r. Pi is the number 3.14159. There is a pi button in the calculator. I'd prefer you just use the pi button in the calculator. So that's how you calculate circumference. A series of crop circles were discovered. Great, we don't care. The largest of the 3 circles had a radius of 30 feet. Find its circumference. Circumference is 2 times pi times r. So the circumference is 2 times pi times 30, which is 60 times pi, which is, I don't know, 60 times 3.14. 180, 180 something. No. I don't have it. 186 maybe? 187? Let's do 60 pi on the calculator. 60 pi, 188. 188.5 roughly it rounds to. That is circumference. We have a circumference question that asks us to solve for the radius. Nope, that asks us to find the circumference given the diameter. This one we want to half this to get the radius and then use that. Find the diameter and the radius. Okay, so this is what I want to do. Circumference is 2 times pi times r. Fill in what you know. What do we know? We know the circumference is 65.4. Keep in mind, 2 pi is a number. It's 2 times 3.14. And to be exact, 2 pi is 6.28. Okay? So if we want to solve for r, we just divide by 2 pi. So our radius is 65.4 divided by 2 pi. Hold on, let me make sure I'm typing this in my calculator right. I was not. So you gotta be careful there, holy cow. 10.4. So when you type this in the calculator, you have to put 2 pi in parentheses, or else it'll do 65 divided by 2, and then it'll multiply it by pi. You don't want that. So your answer here is radius is 10.4, so therefore the diameter is double that, which is 20.8. All right, let's be done with this video. Come on, Mr. Bird. Come on. I think there's inscribed and circumscribed at the end of this chapter. Oh, you know what? This is the last one I'm doing here. Last one. Find the circumference. Love this. Right triangle. Just did right triangles. And guess what? The sides of this right triangle are both a radius of the circle. So they're both equal to each other, which makes this an isosceles triangle, which makes it a special right triangle. 45, 45, 90 degree triangle. A 45, 45, 90 degree triangle has a special kind of relationship where the hypotenuse is the side length times the square root of 2. And if you look, that hypotenuse already has the square root of 2 on it, so that means that these side lengths are just 3. All right, which means my radius is 3, which is great because I can just use the radius to find the circumference. The circumference is 2 times pi times r, which is 2 times pi times 3, which is what? I don't know. Let's grab a calculator. 2 times pi times 3, 18.85. Love it, hate it, it's great. All right, that's going to be it for this video. Like and subscribe to the channel. Right now, like and subscribe.